Alright, now let's look at another problem which basically says check if a given number is a perfect square or not. So ultimately here you will be given a number in the input and write a program to check if the given number is a perfect square. If so, return true, otherwise return false. So here let's look at some of the examples. Right here the input number that we've gotten is 16. 16 is nothing but 4 multiplied by 4, so it is a perfect square, so we have written true. Here another input is 1. 1 is nothing but 1 multiplied by 1, so we should return true. And here 19, so 19 is not a perfect square, right? We don't have any two whole integers which can be multiplied by itself to give us a result of 19, so the output should be false here. And another input is 64. 64 is nothing but 8 square, so we've written true. And another case that you need to understand here is, since we are passing a number to the user, there is a chance that we can pass some negative numbers as well. Let's just say if I'm passing minus 10, it is also a not perfect square, right? Let's just say if I'm passing minus 64, it is also not perfect square, because there are no two integers which can be, no two negative integers, same negative integers which can be multiplied to give 60 minus 64. Obviously if we multiply minus 8 into 8, that will yield, but they are not same integers because minus 8 is different from plus 8. So that is the understanding that you need to have here. So ultimately if any negative number is coming, then we can't find the number is not a perfect square, so we can return false. Otherwise we need to write the logic. Alright, now let's look at the brute force approach for solving this specific problem. So here, you don't have to consider these values. These values I'm just adding here for explaining you how can we solve this problem in an effective way, that we will be discussing later on. But for now, concentrate here. As part of the brute force approach, what we will do, we will be running a loop from 0 till this I multiplied by I is less than or equal to num. Because once we multiply the number by itself, if it is greater than num, there is no need of checking, right? Because the greater values will never yield as the perfect square numbers. So here, as long as this condition is matching, if at all I multiplied by I is equal to the num, here we can return true. Otherwise, once this logic is completed, checked for all the values, if at all we have not written anything, we need to return false, indicating that the number is not a perfect square. Remember that this is the main core business logic, but before that you will have one more check to check if the given number is negative number. If so, automatically we will return false, right? So that check you can have before this, but just adding if at all the given number is less than 0, you can simply return false then and there itself. Okay, so this is the brute force technique. Okay, now this problem can be solved even in a better way using the binary searching technique. That is what we will be discussing next. Now let's look at binary searching technique for finding if a given number is perfect square or not. So here, since the number that we are going to get is a particular number, right? So the square possibility will be lying from 1 till the given number itself, because we can find any number that can be multiplied by itself to give the given target. So our search range in which we need to find the value will be from 1 till that number itself. If you observe, from 1 to till that number, all the values are increasing, right? So we can apply the binary searching technique. So here, start, we will be initializing it with index 0, end we will be initializing it with the not index 0, basically the value 1. End we will be initializing with whatever the given number itself. Now what we will do, we will be calculating the middle. Middle is nothing but 1 plus 16 divided by 2, which is nothing but 17 by 2, which is nothing but 8.5, which is nothing but 8. So here we have gotten the middle. Now what exactly we do is, once we calculate the middle, we will multiply the middle by itself. So if we multiply middle by itself, what we are getting? 64. But the number that we are looking for is 16. That means at the middle we have the value 8. If we multiply by itself, we are getting 64. But the value we are looking is 16. That means the smaller squared numbers will be on the left part. So what we will do, immediately we will update the end with the middle -1, which is nothing but 7. So right now start is at 1, end is at 7. So again we will calculate the middle. Middle is nothing but 1 plus 7 divided by 2, which is nothing but 4. So here we got the middle. Now middle is nothing but 4. Now 4 multiplied by 4 is nothing but 16. So we have gotten 16. So 16 is a perfect square. So we can immediately return true. Let's just say we've gotten some other number. Then in that case, based on the nature of the value, we either look on the right part or on the left part. Okay, I hope you understood. Here the starting value will be 1, end value will be nothing but whatever the number that we have given. All the numbers are increasing. As a result, we can apply the binary searching technique. We will calculate the middle multiplied by itself. If it is yielding the same number, we can return true because we have gotten the perfect square. Otherwise, the nature of the value that we have gotten from the middle multiplying by itself, either we will search on the left part or on the right part. Okay, so that is the logic here. Now let's try to understand how it is better when we compare it with the brute force approach, right? In the case of brute force approach, if at all we wanted to find if number 16 is a perfect square or not, we have to start from 0 till we need to run till iteration 4. I mean reach the value of 4. Then only we would have gotten it is a perfect square. So it technically would have taken 4 iterations for us to 4 or 5, because we will be starting from 0, right? So it will be taking 5 iterations. At the 5th iteration we will be knowing that it is a perfect square. But by applying the binary searching technique, if you see here, we've gotten to know that it is a perfect square in the 2 iterations itself. Okay, so that is the advantage that we have here. So we will be reducing the number of iterations. Even though the traditional brute force approach will not take the order of n units of time, still whatever the number of iterations that are consumed by the brute force approach, we can minimize them here in the binary searching technique. So that is the understanding that we have here. Okay, so this is one example. Now let me quickly write the function using the binary searching technique. Basically let's write the pseudocode. So let's write one function called check if perfect square. What it does, it will take the number. So immediately whatever the base conditions that we have, like checking if the number is less than 0, those things you can add it in the first itself. And immediately after that, I'm writing the main business logic here. If at all, if you want to see all the logic, you can check the later parts in the implementation. Now here I'm going to initialize the start with 1 and end with the given number itself. And immediately I will define one variable called mid, and I will be initializing it with -1. What we will do, we will be running a loop as long as the start is less than or equal to end. We will calculate the middle. Middle is nothing but start plus end divided by 2. We've gotten the middle. Once we got the middle, what we will do, we will multiply by itself. If middle multiplied by middle is equal to the given number, then we found the perfect square, right? Because the number is matching. So here itself we will be returning the true. If this is not the case, then there are two scenarios, right? Based on the nature of the middle multiplied by middle compared with the number. So if this middle multiplied by middle is greater than the number, then what we need to do, we need to look for the smaller number. Smaller numbers are there on the left side. So here, that is the reason why end we will update it with middle -1. Otherwise, we need to look for the greater numbers. Greater numbers are there on the right side. So here we will update the start with middle +1. Okay, after searching all possibilities, if at all the value is still not found, the value is not a perfect square, after this while loop, we need to return false, indicating that the number is not a perfect square. Okay, so that is the pseudocode for checking if a particular number is a perfect square or not. Okay, remember that whenever this problem is given, you should always go on to solving it with the help of a binary searching technique. Okay, obviously here we can't say the time complexity is order of log n, because traditionally the binary searching algorithms time complexity is order of log n, right? But here it is not even log n, it is basically some number of iterations which we can't say, but traditionally, since it is binary searching technique, it is log n units of time, and the space complexity is obviously constant because we are only initializing 3 or 4 variables. Okay, so that is the logic for basically pseudocode and how we solve if a particular number is a perfect square or not with the help of a brute force as well as binary searching technique. Okay, now that we have seen this, let's quickly go ahead and solve this, write the logic for binary searching technique. If at all, if you want to check out all other technique implementations in all programming languages, you can go to codingpal.org. I'll put the link in the description and you can check the implementations there. Okay, thanks for watching. I'll see you in the implementation.